Hello everyone, welcome to the course Geotechnical Engineering 2. So in this module number 4 and lecture number 5, we will be discussing on the effect of water table that is having on the bearing capacity. Okay, so coming to the course outline, so we are in this phase where we are discussing different methods of determination of bearing capacity, and we have discussed some Terzaghi analysis as well. So now we will be understanding the bearing capacity where we consider the general shear failure, the local shear failure, as well as punching shear failure. And now we will be discussing this with respect to the effect of water table. Okay, so coming to the previous lecture, so we have understood the Terzaghi's bearing capacity theory, where we have considered the general shear failure initially and then the local shear failure, and in general shear failure we have obtained this particular expression for the strip footing. And in case of local shear failure, because it is modified due to the parameters that is C dash and phi dash, so this expression is obtained for the strip footing when it is a local shear failure case. Okay, so these two, how we have derived, we have looked at. So the effect of water table on these parameters of determining the ultimate bearing capacity, now we will look at this more in detail in today's lecture. Okay, now, so the effect of water table on the bearing capacity. So earlier equations whatever we have obtained, these are based on considering the groundwater table at the surface. Okay, now these have to be modified considering the depth of water table. Okay, now these has to be modified considering the depth of the water table. So for this we have two different cases. One case is considering the water table above the base of the footing, and the other case is considering the water table below the base of the footing. And in this aspect, if you look at this particular diagram here, so this case is for when the water table is above the base of the footing, and the case B is when the water table is at a depth say B, which is below the footing. So for these two cases we will try to understand the change in ultimate bearing capacity as well as the other parameters, that is bearing capacity factors NC, NQ and gamma. Okay, let us look at this more in detail now. So coming to the case 1. Okay, so when the depth of the water table is above the base of the footing, that means let us consider this as a footing. Let us consider this as a footing. Okay, and this is the ground level. This is the ground level, and let us say the water table is now at somewhere here. This is the groundwater table. Okay, let us consider this depth as capital DW, and let us consider it is at a distance of A from the foundation base, and let df be the depth of foundation, df be the depth of foundation, and B, capital B, be the width of the base of the foundation, width of the base of the foundation. Clear? So for this particular case, let us try to obtain the values of ultimate bearing capacity. So here the effective surcharge that is present above this particular base of the footing, okay, so it is actually now in a submerged state. Okay, so that means we have to consider the effective weight here. So that would be obtained in this manner. So now this Q whatever we have, that will actually vary, because considering the surcharge term in our bearing capacity expression, we can denote that this will be gamma into dW plus, since this is submerged now, so this has to be considered gamma dash into A. Okay, so this Q whatever that we are considering in the surcharge term, that will vary now. And here if you consider this A can be written as from the diagram df minus dw. So upon further simplification, this is gamma dw plus gamma dash into, this can be written as df minus dw. Okay, so upon further simplification I can write down gamma dash into df as one term, plus this is gamma dw minus gamma into dw minus gamma dash dw, or simply gamma dash df minus of gamma dash minus gamma into dw. So this is what I can write down as q, the surcharge term in our bearing capacity expression. Okay, so let us substitute this in our expression. What we know, so we know that qu, the ultimate bearing capacity, is equals to 0.5 gamma b and gamma plus c and c plus q here is gamma dash into df minus gamma dash minus gamma dw into nq. Okay, substituting these values we can write down this as the ultimate bearing capacity equation. But in this term, if you look at this part, since it is above, this term will be gamma dash b and gamma dash b and gamma. So that is the only difference here. So this is the ultimate bearing capacity expression what we have obtained when the groundwater table is above the base of footing at a height of a. Okay, so now if you observe here, when the value of a is equal to df, that means when a is equal to df. Okay, let us say now a is equal to df. So when a value is equal to df, then obviously I can state that this is gamma dw plus gamma dash df. Okay, that means simply this dw equal to 0 now. So in such case this will be gamma dw plus gamma dash df. Okay, and this term will be 0. So simply q will be gamma dash into df. So in this case simply gamma dash, okay, since dw is 0 and a is df, this gamma dash df is equal to q. Okay, in this case this will be the case. Okay, so substituting you will get the expression as 0.5 gamma dash b and gamma plus c and c plus gamma dash df into nq. Okay, so that is the term. Now if you say the other case, a is equal to 0. Okay, when a is equal to 0, so obviously when a is 0, dw will be equal to df. So in this term our q value will be equal to gamma into df. Clear? It will be gamma into df. So that is how this expression will vary. Clear? So this is regarding the groundwater table above the base of the footing at a depth a. So now let us consider the case 2. Case 2. Okay. So in a similar case, let us try to consider the diagram once again. Imagine there is a foundation. There is a foundation of width b and this is the ground level. And now let us consider the foundation, and now let us consider below the foundation there is groundwater table. This is the groundwater table. So let this be at a distance of small b below the foundation, and let the width of the foundation be capital B, and this be df. This is df, the depth of foundation. So this is our case 2. So if you look at this particular diagram, the water table is somewhere below the base, so the surcharge term is now not affected. However, the other term that is there, okay, the failure term considering the shear zone, so that will vary, okay, and that has to be modified. And here it is given by, let us denote that as gamma bar, okay, in the term of ultimate bearing capacity, that is 0.5 gamma b n gamma. So let us denote the term as gamma bar. So that gamma bar is given by gamma dash plus small b by capital B into gamma minus gamma dash. Okay, so this is the term that is changing now. So using these equation, now let us try to substitute, because only the surcharge term is not changing here, because the water table is below, the surcharge term is not at all affecting. The only term that is affecting is the shear zone term. So let us substitute this in the equation of ultimate bearing capacity, what we know. So that is, we know Qu is equals to, let us write the CNC term first, CNC plus Q NQ, okay, plus 0.5 gamma into B. Here the gamma is gamma bar B and gamma bar B and gamma. So in this case, so substituting the values, we can write down this as CNC plus gamma DF into NQ plus 0.5 gamma bar is gamma dash plus B by capital B into gamma minus gamma bar or gamma dash into B and gamma. Okay, so this is for the general shear failure case, but if you have to consider local shear failure, consider the bearing capacity terms in that manner. Okay, so this is the final expression when the depth of the groundwater table is at a level below the base of the foundation, okay, at somewhere say B. Okay, so when, let us consider two cases here as well. When small b is equal to 0, okay, when I substitute b is 0, let us look at this term, since these are not getting affected. Okay, look at this particular term here. When b is 0, obviously this term is 0, so this will be 0.5 gamma dash b and gamma. I will just write sigma bar here. This is gamma dash term only. Okay, and the other case when b is equal to capital B, when this b is somewhere, that means the groundwater table is somewhere at a depth below the base of the foundation, where that depth is equal to the width of the footing. So in such case, what is gamma bar? Substitute b as capital B, so this will be 1 gamma dash plus gamma minus gamma dash, so it will be simply equal to gamma. So your gamma bar will be equal to gamma in this case. Clear? So substituting these two in Qu, we can find out the ultimate bearing capacity for this particular case when the depth of water table is below the base of the footing. So I think this is clear. Now in the upcoming lecture, we will try to discuss the other method that is there, Indian standard method, as well as we will be starting the settlement criteria as well, the introduction to settlement criteria in the upcoming lecture. Okay, so I hope you have understood very well today's lecture. So that's it for today. Thank you very much. Have a nice day.